Hello, students, and welcome to another algebra lesson. My name is Mr. Nguyen. Today, we're going to learn about domain and range of continuous functions and how to use different notations to write the domain and range. So I have a couple of questions for you. These are essential questions for you to think about. First, how do we find and denote the domain and range of a continuous function? So today, through this lesson, you're going to learn how to do that. And how does understanding the restriction on the domain and range help us further understand the function? This is something you have to think about for future classes. So in this lesson, we're going to learn how to find the domain and range of functions and how to write the domain and range using different notations, including inequality notation, set builder notation, and interval notation. So let's review a little bit about the business of open circle versus a closed circle on a graph. So remember, this is something you've learned in the past, that whenever your graph has an open circle at the endpoint, this indicates exclusion. That means you don't include that value. So for example, here as you can see, 5 has an open circle on the number to indicate that we can include any value that is close enough to 5 or bigger than 5, but not exactly 5, because that value will somehow make the function undefined, okay? Or the function is not defined that value, so we cannot include it. So this is called an exclusion in the domain, okay? Um, Opposite of that would be the closed circle. The closed circle indicates that we do need to include the value. So 10 would be a valid value for the function, okay? And goes with these open circle, we use the inequality symbol without the equal sign. And then for closed circle, we use the equal sign with the inequality symbol because we do want to include that value, okay? So here are the three different notations that we're going to be talking about today. The first one you already know, the inequality notation. We learned this in previous grade levels, right? We learned how to use inequality notation to indicate the values that the variable falls between, right? So for this example, the values, the variable falls between 5 and 10, including 10, right? Set builder notation is very similar to inequality, except it has a little um, bracket, the curly brackets on the end, and as you can see, the inequality is exactly the same. So how do we read this? We're going to learn how to read this, right? And then interval notation is the most simplistic way to write your domain or range, right? So in this case, instead of putting h as a variable in there, we throw in a comma to indicate that whatever the variable is, it falls between 5 and 10, or you can say that it goes from 5 to 10, right? Since it is an interval. And the parentheses versus the bracket does have significance here. The parentheses is to signifies the open circle, right? The non-inclusion. And then the bracket means the inclusion, right? We want to include the value. So not equal to, equal to. So we're excluding 5 and we're including 10. And then the domain or the range would be whatever, everything that is in between these two numbers. Okay, so that's a lot of them, right? All right, so if you were doing this with me as a class, I would have you rewrite this interval notation uh, or inequality notation into an interval notation. So you would drag this little icon right here. Oh, sorry. You would drag that little star icon and put it in the correct response. So let's take a look at this real quick. If you notice, the inequality indicates -8 and 8, and x would be everything between that, right? And then we have an equal sign here. That means we do want to include the -8, but we don't want to include 8. So put this in interval notation means we do have a bracket on this end and parentheses on this end and a comma in between -8 and 8. So let's see which one that is. It looks to me like it's going to be this one right here, the -8 with the bracket and the +8 without the bracket with the parentheses instead, okay, to indicate not equal. So you should have selected that one. Again, you're going to write a response if you were doing this lesson with me. But since I'm recording this, we're going to work this out together. What is the smallest value of the domain? Okay, so you've learned this before. To read the domain on a graph, you must read along the x-axis of the graph, right? So here's our graph. We just have a piece of a line, right? A line segment. And it looks to me, if I'm reading on the x-axis, it looks to me like it starts on the left at -2. And I have a closed circle, so I am going to include that -2. So your response should have been a -2 would be the smallest value in this domain, okay? So how do I write the domain for this graph? Well, so we're gonna look from left to right like I did, okay? And it looks like that the graph starts at -2 on the left, including it, right, with a closed circle. So I'm gonna include that value in my domain. And the graph keep traveling to the right and looks like it stopped at 5. So, and I have an open circle means I'm going to exclude that value, okay? So let's rethink about how that factors into our inequality notation. Because we include the value at -2, we want to have an equal sign. And we don't want to include 5, so we don't put an equal sign there. So this is the inequality notation to indicate that x lives in between these two numbers. So everything in between these two numbers would be a valid value for the variable x. Set builder notation, we just take that inequality and we put it into set builder notation with this little symbol right here. Well, what does this say then? It says the domain, since it is x value, the domain is the set of all x value, the set. So the curly bracket means the set of all x value. And this little bar right here means such that. So this in math reads as such that, okay? So x, the domain is all the x values such that x is greater than or equal to -2 and it is less than 5, okay? So that's how we read this entire thing. So as you can see, in math, we use all of these notation to sort of shorten to simplify what we need to communicate to other people, right? I mean, we can say this every time we write the domain down, but as you can see, how long that would take, right? So we use this notation to for the sake of simplicity, okay? Interval, as I mentioned before, interval is the simplest way to indicate either domain or range. The thing about interval notation is it does not tell you which variable. So you do when you do interval notation, you do have to mention what the interval is for. Is it for domain or is it for range? So you do have to indicate to whoever you're writing it for, whether you're your teacher or a textbook or your work, your homework. You have to indicate, hey, this is the domain by putting a D in front or an R for range, right? So interval notation is used a lot in colleges. And universities, upper math level classes, they use interval notation a lot, again, for simplicity. So we use bracket because there is an equal sign, and we use parentheses because there is no equal sign, okay? So as you can see the relationship there. Spring break, that's a lot of math already. If you could learn one of these skills, which would you rather learn? What would you like to learn? Would you like to learn how to sing, how to dance, and it looks like this guy is breakdancing, or how to paint, or how to do martial arts, do some kung fu? I don't know. I've always loved dancing. I like to sing too, but I do not have the talent. I think singing needs to come with a talent. So does painting, but I don't know. I like painting. I probably would pick up painting. Yeah, that's I would choose painting. Anyway, I like to hear what you guys would choose. All right, let's get back to math here. What is the lowest value of the range? Okay, so it's the same graph, but now we're reading it differently, right? Remember when you learned this in your maybe your lower math classes, that to read the range, it has to do with the y variable. So we're going to be reading up and down, or more precisely from the bottom to the top, right? So we're going to look at the bottom value here, which is a -3, and that indicates the lowest value of this range. So if you were to do this on your own, you would input the number -3 for me, okay? How do I write the range for this graph then? Okay, well, similar to writing the domain for this graph, but I will look from bottom to top instead of from left to right, because we're dealing with the y-axis now, right? So I look from the bottom to the top, and I see that the graph starts at -3 with a closed circle, and so I will include that -3, and then I keep traveling and traveling, and looks like my graph travel up, but then it stops at 1 on the y-axis, right? It stops at 5 on the x-axis, but it stops at 1 on the y-axis, and there is an open circle, so I do not include that 1, right? So I will exclude my 1 in my range. Okay, so how do I write this then? Well, similar to how you write the domain, except now you're going to be using the y variable, right? And of course different numbers, the -3 with the equal sign because it is a closed circle, and then all the way up to 1 with an open circle, so no equal sign. Okay, and take that and put it in your set notation with the y variable. So it's going to read, the range is the set of all y values such that y is greater than or equal to -3 and less than 1. Okay, and then, of course, we're going to simplify this even more and write it in interval notation, from -3, comma 1. So from -3 to 1, include -3, excluding 1. Okay? Find the range of this graph. Okay. Well, take a minute and try it on your own, and then I will tell you what the answer is. You can pause this video, by the way, or you can fast forward it if you like to get to the later content. All right, so look at this right here. The graph looks like it starts, if I'm doing the range, right? Remember, range is up and down. It looks like it starts at the origin, which is 0. And then it keep going up and 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 up. And then the arrow key indicates that it keep going indefinitely, right? So it starts at 0 and then up to the positive infinity direction. So I would say that anything greater than y is anything greater than 0. Y is anything greater than 0, including 0. I want to include 0 because there is no open circle here. When there's no open circle, you have to assume that it does include the value, okay? Just for future reference. If they want to exclude the value, they will indicate it and they will let you know. If they do not indicate exclusion, then you will assume that you include that value. So look at all these choices. X is wrong because I'm not doing domain. All real numbers is wrong because I'm not including any of these negative values down here for my graph. The last choice is also wrong because this is how you list a discrete range, right? You list the number discretely. That means from 0 to 1, that means there is nothing in between. That means it is discrete. So our most viable choice is this one right here. Okay, y is greater than or equal to 0. State the range of this graph. Okay, again, we're doing range. So be sure to read the question correctly or read the problem and don't just assume that it's asking for whatever you want it to ask. It's asking for range. So we are going up and down. So from bottom, start at the bottom of your graph. It looks like it starts at 1 because I'm going to assume that's a 2 up here, right? This is a 1. So it starts at 1 and it keep going and up and up and up and up. And it looks like the graph stops at 5, not 6. 6 is this number up here. Okay, so I'm just going to count my line. 1 and then 1, 2, 3, 4, 5. So it stops at 5. Okay. Oh, well, here's our answer choices. But the X answer choices are wrong because we are not doing domain. So you can eliminate those two choices, which leave us with these two. Well, what's the difference between them? One of them have equal sign, the other one does not have equal sign. So, and we have closed circles, so our answer choice should be this one right here. Y is between 1 and 5. And what is this notation called? You got it? Inequality. Inequality. State the domain of this graph. Oh, finally, a domain one. So domain along the x-axis, and I'm going to assume each of these little line is 1 unit. So always look from the left and go to the right on the graph, right? From the left, it looks like it starts at -1, -2, -3, -4, -5, -6, -7, including the value. So I know I have an equal sign. And then I keep going and going to here, which is 1, 2, 3, 4, 5. So I go from -7 all the way to 5, not including 5. So I know this answer choice is wrong. This answer choice is wrong. That leaves me with these two. So what's the difference between them? Oh, the difference between them is the variable. This last choice is wrong because it has to do with y variable. So our answer should be the first one, okay? Oh, now they want the range. Okay, same graph, but we're gonna read it from bottom to top. Okay, so from the bottom, it looks like my graph starts at -3, and then I keep going and going and going and stops at 1. Okay, now -3 I do want to include. 1 I don't want to include 1. So that leaves me with these two answer choices from -3 to 1. But now I'm dealing with the range, so it's y variable. So my answer choice is this one right here. Okay. Let's recap some of the main points really quick. As we know, the domain can be found by finding all the input values. If we have order pairs, so these would be considered the discrete value, or you can write all the input values written as an equation, so that would be continuous, right? So that's the difference between discrete and continuous. We didn't do any discrete example, so to say. We did talk about it briefly from one of the answers, but and the range is determined by all the outputs of the function or of the order pair. Again, order pair is when you're dealing with discrete values, and then equation or graph is when you're dealing with a continuous. So for many functions, the domain can be found by reading the graph from left to right, and the domain can be found by reading the graph from bottom to top. Okay. Interval values represented on the number line or the graph or the axis can be described using inequality notation, set builder notation, and interval notation. That's those three notations we have seen. Also remind yourself to use parentheses, open circles, or no equal sign to indicate exclusion. That means you don't include those values. And we use brackets, closed circles, and the equal sign to indicate that we do include the values. Okay, so these are some of the main points that we touched on in this lesson. I hope you guys remember them.